Please, let me ask you, why do you think that there is perhaps some mystery here that you're raising questions? That's something that was clearly seen by the Hubble Space Telescope. Scientists thought they had space rocks all figured out. Comets heat up near the sun, release water and gases, grow tails. Pretty standard stuff. But then 3 Atlas showed up from outside our solar system and started breaking every rule. NASA's most advanced telescope studied it weeks ago and won't tell us what they found. Is this just a really weird space rock, or are we looking at evidence of extraterrestrial technology? The space rock that's breaking every single rule we know. When scientists first spotted 3I Atlas back in February 2024, it was moving at over 33 kilometers per second, which is fast enough to zip from one coast of America to the other in just over 2 minutes. That speed alone told them this thing wasn't from around here, because anything moving that fast is definitely not stuck in orbit around our sun. The name itself tells the whole story. That 3I means it's the third interstellar object we've ever confirmed, following the weird cigar-shaped Oumuamua in 2017 and the more normal-acting 2I Boris in 2019. But here's where things get really interesting. Unlike those previous visitors that we could only watch for a few days or months before they disappeared, 3I Atlas has been visible for over a year and a half. Scientists have been able to track this thing continuously, watching it get brighter as it approaches the sun. And what they're seeing is completely rewriting the textbooks. When it was first discovered, you needed a massive telescope just to see it. But now it's gotten bright enough that serious amateur astronomers with good equipment can actually spot it themselves. The really wild part is that this object entered our solar system at almost a perfect right angle to where all our planets orbit. But then its path curves in such a way that it's going to pass relatively close to several major planets during its visit. It already flew by Mars this past July, close enough that any spacecraft we have orbiting Mars could have gotten incredible pictures if NASA had bothered to point them in the right direction. Now it's heading toward Jupiter for another close encounter in November. What are the odds of that happening by pure chance? Astronomers have run the numbers, and we're talking about something like a 1 in 500 chance that a random space rock would follow this kind of trajectory. That might not sound impossible, but when you start adding up all the other weird things about this object, those odds get a lot more suspicious. Space Telescope reveals the impossible. NASA has this incredible space telescope called Sphere-X that cost them almost $250 million to build and launch. This thing operates in infrared light, which means it can see heat signatures and chemical fingerprints that are completely invisible to our eyes. Think of it like having superpowered vision that can tell you exactly what something is made of just by looking at the light it gives off. The telescope is so sensitive that it has to be cooled down to almost absolute zero just to prevent its own heat from interfering with the measurements. Between August 8th and 12th this year, NASA turned this incredible machine toward 3I Atlas and took detailed measurements every 12 hours for 5 straight days. What they found was so strange that it's causing major arguments among scientists about whether our understanding of space objects is completely wrong. The telescope detected this massive cloud of carbon dioxide gas pouring off the object at a rate of about 70 kilograms every single second. That's like having a fire hose that never stops flowing, except instead of water, it's shooting out enough CO2 to fill up several cars every minute. Now, you might think that sounds normal for a comet getting heated up by the sun. But here's the kicker. When Sphere-X looked for water vapor, which should absolutely be there if this is a normal comet, it found nothing. Zero. Not even tiny traces. This telescope is so sensitive it could detect water being released at less than 5 kilograms per second. But there wasn't even that much. For an object at this distance from the sun, where comets typically start steaming like crazy, finding no water at all is like discovering a campfire that produces smoke but no heat. Even weirder, there was also no carbon monoxide detected, which is another gas that should definitely be coming off any normal comet at this distance. In the entire history of studying comets, we have never found one that only releases carbon dioxide without any water or carbon monoxide. It's not just unusual. It breaks the basic laws of chemistry and physics that govern how these objects are supposed to behave. The purity of this CO2 emission is what's really freaking out scientists. Normal comets release a cocktail of dozens of different gases and compounds when they get heated up because they're basically ancient dirty snowballs made of all kinds of frozen materials mixed together. The spectrum from 3I Atlas shows just this one clean carbon dioxide signature with virtually nothing else, which has never been seen before in nature. But it gets even stranger. The isotope ratios in this CO2 are wrong. Isotopes are like different flavors of the same element. And the mix of these flavors tells you about where and how something formed. The carbon and oxygen in 3I Atlas have isotope ratios that don't match what we see anywhere else in our solar system. And they also don't match what we'd expect from typical interstellar material either. It's like finding a rock made of elements that don't exist on Earth. A size that breaks all the math. When scientists calculated how big 3I Atlas actually is based on all the heat and light it's giving off, they got an answer that shouldn't be possible. This thing appears to be about 46 kilometers across, which is bigger than most major cities. If you dropped it on top of New York, it would cover Manhattan, Brooklyn, Queens, and then some. That might not sound huge compared to planets, but for a space rock, it's absolutely massive. To put this in perspective, the only other interstellar comet we've studied, 2I Boris, is less than 1 kilometer across. That makes 3I Atlas roughly 1,000,000 times more massive than our previous interstellar visitor. The first interstellar object, Oumuamua, is even smaller at only about 200 m long, making 3I Atlas potentially millions of times bigger than that one too. Here's why this size is such a huge problem for scientists. If space between the stars contained enough large objects for us to randomly run into something this massive, then basic probability says we should have found hundreds or thousands of smaller interstellar objects first. It's like claiming the first fish you ever caught was a whale while insisting the ocean is full of normal-sized fish. The math just doesn't work unless something very unusual is going on. Avi Loeb, who's a Harvard astronomer that's been following this story closely, ran the calculations on how much rocky material should be floating around between the stars. He found that there's about 10,000 times too little stuff out there to account for randomly finding an object this size. It's not just improbable, it's so unlikely that it challenges our basic understanding of what should exist in the galaxy. Think about it this way. For an object this large to form naturally and then get ejected from its home star system with enough speed to travel between stars would require a chain of events so unlikely that finding it here is like winning the cosmic lottery. Either our models of how space works are completely wrong or 3I Atlas isn't following the normal rules of how objects move through the galaxy. The size calculation was double-checked using different methods and they all give the same answer. Scientists measured both the heat it gives off and the sunlight it reflects, and both techniques point to something around 46 kilometers across. The consistency of these measurements makes it hard to argue that there's some kind of measurement error or misunderstanding about what they're looking at. The missing light show. Here's another thing that makes absolutely no sense about 3I Atlas. When comets get close to the sun and start releasing gases, they don't just blow off vapor. They also release tons of tiny dust particles that get carried along with the sublimating ice, creating these spectacular glowing halos and tails that make comets some of the most beautiful sights in astronomy. But when Sphere-X looked at 3 Atlas, it saw the object as almost a perfect point of light, like a star. There's no significant dust cloud around it at all. This is completely backwards from what should be happening with any active comet at this distance from the Sun. The absence of dust is so complete that scientists estimate there are at least 10,000 times fewer particles around 3I Atlas than you'd find around a typical comet. The Hubble Space Telescope did take some pictures earlier this year that showed some kind of glow around the object, but even that was weird. Instead of the fan-shaped tail that should be streaming behind any comet due to solar wind and radiation pressure, the material around 3 Atlas forms this almost circular halo that spreads out equally in all directions. Even stranger, some of the brightest parts of this halo seem to be positioned in front of the object rather than behind it. This makes no sense according to the basic physics of how the solar wind works. The sun is constantly blasting out charged particles at hundreds of kilometers/s. And these particles should push any dust away from the sun, creating the classic comet tail that always points away from our star. For material to be positioned ahead of 3I Atlas in its direction of travel goes against everything we know about how dust behaves in space. Some scientists think maybe the glow isn't coming from dust particles at all, but from some kind of ionized gas or plasma effect. But that would require an energy source way beyond simple solar heating. And nobody can figure out what that energy source might be. It's like finding a flashlight that glows without batteries. The lack of dust also creates problems for understanding how 3I Atlas is releasing so much CO2. Normal comets produce dust and gas together because the sublimating ice carries particles along with it. Finding massive gas release with virtually no dust suggests either that this object has a completely different internal structure than any comet we've seen, or that the CO2 is being produced through some process that doesn't involve normal ice sublimation. A perfect path. The trajectory that 3 Atlas is following through our solar system is so convenient and well planned that it's hard to believe it happened by accident. This object didn't just randomly wander in from interstellar space. It approached our solar system in a way that brings it close to multiple planets during a single visit, maximizing the opportunities for any hypothetical observers to study our cosmic neighborhood. The path started with that close pass by Mars in July when 3I Atlas came within about 22 million kilometers of the red planet. That's close enough for detailed observations by any of the spacecraft we have orbiting Mars. Though NASA apparently didn't bother to redirect any of them to take a closer look. Now the trajectory is carrying it toward Jupiter, where it will pass within about 127 million kilometers of the giant planet in November. For a truly random interstellar object, the chances of achieving close encounters with two different major planets during the same solar system passage are incredibly small. Computer simulations show that less than 0.1% of random trajectories would result in this kind of multiplanet tour. When you combine this with all the other statistical anomalies surrounding 3 Atlas, you start to wonder if any of it is really random at all. The timing is suspicious too. 3 Atlas reached Mars during the summer when Mars was at opposition, meaning Earth was positioned directly between Mars and the Sun. This gave Earth-based telescopes the best possible viewing conditions for observing the encounter. The Jupiter approach in November will happen during Jupiter's opposition season, when the giant planet is closest to Earth and positioned for all observation. It's like this object is deliberately timing its visits to give us the best possible opportunities to study it. The overall trajectory also aligns much more closely with our solar system's orbital plane than it should for a random visitor. Most interstellar objects should approach from completely arbitrary directions. But 3 Atlas came in at an angle that brings it through the flat disk where all our planets orbit. This is exactly the path you'd choose if you wanted to get close looks at as many planets as possible during a single pass through the system. What makes this even more interesting is that 3 Atlas is moving relatively slowly compared to other interstellar visitors. Its speed through interstellar space before entering our solar system was only about 5 kilometers per second, which is much slower than the 20 to 30 kilometers per second you'd expect for objects ejected from other star systems. This slower speed suggests either that it didn't travel very far to get here or that it was deliberately slowed down for some reason. Chemical signatures. The detailed chemical analysis of 3 Atlas reveals features that don't match any known natural processes or materials. Beyond the basic problem of finding only CO2 without water or carbon monoxide, the isotope ratios in the carbon dioxide show signs of what looks like artificial processing or formation under highly unusual conditions. When scientists use the most powerful ground-based telescopes to analyze the exact composition of the CO2 being released, they find that the ratio of carbon-13 to carbon-12 is about 13% higher than what we see in our solar system. The oxygen isotope ratios are even more deviant, showing enhancements of about 9% above solar system standards. These might sound like small differences, but in the world of isotope chemistry, they're huge red flags that indicate this material formed under very different conditions than anything in our cosmic neighborhood. Isotope ratios are incredibly important because they tell you about the nuclear processes that created the atoms in the first place. Different types of stars produce different isotope mixes depending on their size, age, and evolutionary stage. Computer models of how chemical elements spread throughout our galaxy predict what isotope ratios should look like for material that comes from different regions or stellar environments. The problem is that the ratios found in 3 Atlas don't match the predictions for any known natural stellar environment. They fall way outside the ranges that should exist anywhere in our part of the galaxy, sitting more than 8 standard deviations away from what's possible through normal star formation and evolution processes. This suggests either that this object formed in some extremely unusual stellar environment that we've never seen before, or that its constituent materials have been processed through artificial nuclear reactions. The emission lines themselves also show strange properties that don't match normal thermal processes. When molecules get heated up and release light, the width and shape of their spectral lines depend on their temperature and the randomness of their motion. The CO2 lines from 3 Atlas show widths that correspond to a temperature of only 89 Kelvin, even though surface temperature measurements indicate the object should be much hotter at around 160 Kelvin. This temperature discrepancy suggests that the CO2 molecules aren't being released through normal sublimation of heated ice. Instead, they might be coming from chemical reactions, electrical processes, or some kind of mechanical ejection system that accelerates molecules to specific velocities rather than the random thermal distribution you'd expect from solar heating. It's like finding exhaust from a car engine when you expected steam from boiling water. The James Webb Mystery. Here's something that should be setting off alarm bells for everyone following this story. The James Webb Space Telescope, which is hands down the most powerful and sophisticated astronomical instrument humanity has ever built, observed 3 Atlas on August 6. That was almost a month ago. And NASA still hasn't released a single piece of information about what they found. This delay is completely unprecedented and highly suspicious. James Webb observations of interesting objects are typically processed and released within days or weeks at most because the whole point of the telescope is to make discoveries that can be shared with scientists around the world for further study. The fact that we're still waiting for any results from the August 6th observation is extremely unusual and suggests that whatever they found is either incredibly complex, technically problematic, or so significant that NASA is taking extra time to figure out how to handle it. James Webb represents the absolute pinnacle of our current technology for studying objects in space. It can detect and analyze trace amounts of hundreds of different chemical compounds, measure temperature distributions across object surfaces, and potentially identify artificial materials or geometric structures that no other instrument could see. If 3E Atlas really does have artificial components or unusual materials that explain its bizarre behavior, James Webb would be our best and possibly only chance of detecting the evidence. The telescope observed 3I Atlas for over 4 hours using multiple instruments simultaneously, which is an unusually long observation time. That indicates NASA considered this a very high priority target. The near-infrared spectrograph can detect chemical signatures with incredible precision, while the mid-infrared instrument can identify mineral compositions and thermal properties that would reveal artificial materials or internal heat sources. Under normal circumstances, if the observations had simply failed due to technical problems or if they hadn't found anything interesting, NASA would have announced that by now. The continued complete silence about what the most advanced telescope in human history saw when it looked at the strangest object ever to visit our solar system is raising questions about what they might be trying to hide or how they're planning to release potentially world-changing information. The timing of this silence is particularly suspicious given that several other space agencies and research institutions are also studying 3I Atlas with their own instruments. If James Webb found evidence of artificial technology or materials, NASA might be coordinating with international partners to decide how to announce such a discovery to the world. The confirmation of extraterrestrial technology would be one of the most important events in human history. And it's exactly the kind of announcement that would require careful preparation and verification. What happens next? Right now, 3E Atlas is still approaching closer to both Earth and the Sun, giving us a rapidly closing window of opportunity to study this object before it disappears back into the darkness of interstellar space forever. The object will reach its closest approach to Earth on October 12 when it will be about 265 million kilometers away and appear significantly brighter than it does now. This represents our best and possibly last chance to get detailed observations of this mysterious visitor. Major observatories around the world have already reserved telescope time during this period, and several space agencies are reportedly considering whether to redirect existing spacecraft to get closer looks. The Juno probe, currently studying Jupiter, could potentially be reprogrammed to observe 3 Atlas during its November approach to the giant planet. Ground-based radar facilities are also planning to attempt detection of the object as it gets closer, though it's still probably too far away for radar signals to make the round trip successfully. Radar observations could provide crucial information about the object's exact size, shape, surface properties, and rotation rate that might help determine whether it's a natural object with unusual properties or something that's been artificially modified. The trajectory calculations show that 3I Atlas will reach its closest point to the Sun on January 3, 2026 when it will be about 176 million kilometers away. That's actually farther from the Sun than Earth's orbit, which means this object will never experience the intense heating that typically causes dramatic changes in comet behavior. After that point, it will begin its journey back toward the outer solar system and eventually into interstellar space, becoming fainter and more difficult to observe until it disappears completely sometime in late 2026 or early 2027. The decisions that NASA and other space agencies make over the next few months could determine whether we get answers to the questions this object has raised or whether 3 Atlas becomes one of the greatest unsolved mysteries in the history of astronomy. If this really is evidence of extraterrestrial technology or artificial modification, then the next few months might be our only chance to prove it before the evidence disappears forever into the cosmic void. The implications of either outcome are staggering. If 3 Atlas turns out to be a natural object that just happens to violate everything we thought we knew about comets and space rocks, then our textbooks are wrong. And we need to completely revise our understanding of how these objects form and behave. But if it turns out to be artificial, whether it's a probe, a modified asteroid, or something else entirely, then it means we're not alone in the universe. And we're dealing with technology from a civilization advanced enough to send objects on journeys between the stars. The evidence keeps piling up. Every single new observation of 3I Atlas just makes the mystery deeper and more impossible to explain using natural processes. We now have an object that's releasing only carbon dioxide with no water or carbon monoxide, which has never been observed in any natural comet. It has isotope ratios that don't match anything that should exist in our part of the galaxy. It's potentially 1,000,000 times more massive than it should be for a random interstellar object. It's following a trajectory that seems specifically designed to provide optimal viewing opportunities for Earth-based observers. The object shows no significant dust emission despite active outgassing. And what little material dust surround it behaves in ways that violate the basic physics of how dust should interact with solar radiation and the solar wind. The spectroscopic signatures suggest non-thermal processes that don't match simple solar heating of natural materials. And NASA's most advanced telescope has been studying it for weeks without releasing any information about what they found. Each one of these anomalies would be interesting by itself, but when they all occur together in the same object, they create a pattern that becomes increasingly difficult to dismiss as natural phenomena. We're not just dealing with one or two unusual measurements that might be explained by instrument errors or previously unknown natural processes. We're looking at a systematic pattern of impossible characteristics that all point in the same direction. The statistical probability of all these unlikely events occurring together in a single natural object is so small that it challenges the basic assumption that 3I Atlas is a random piece of space debris from another star system. When you multiply together all the individual probabilities for the trajectory alignment, the chemical composition, the size distribution, the isotope ratios, and the dust dynamics, you get numbers so tiny that they're essentially zero. At some point, when enough impossible things happen together, you have to start considering explanations that seemed ridiculous when you only had one or two pieces of the puzzle. The possibility that 3I Atlas represents some form of extraterrestrial technology or artificially modified object is no longer a fringe theory that can be dismissed without serious consideration. It's becoming the most plausible explanation for a growing mountain of evidence that doesn't fit any natural scenario. The next few months will be crucial for determining which explanation is correct. If 3I Atlas continues to behave in ways that violate natural processes as it gets closer to the Sun and becomes more active, the case for artificial origin will become even stronger. If it suddenly starts acting like a normal comet and showing the expected water vapor, dust emission, and chemical signatures, then maybe we're just looking at some previously unknown type of natural object that formed under very unusual conditions. But based on everything we've observed so far, 3I Atlas appears to be something that shouldn't exist according to our current understanding of the universe. And that's exactly the kind of discovery that has the potential to change everything we thought we knew about our place in the cosmos. Thanks for watching another episode. While you are still here, make sure to click the video on your screen for more quality content.